Hello everyone. Part 2, I'm going to be attempting problems 13 through 17. We'll start with problem 13. Find the area bounded by the graph of y equals 3x squared plus x, the x-axis, and the vertical lines x equals 1 and x equals 3. This one's very easy. Since you're going with the x-axis, you can just take the integral of that value, 3x squared plus 2 dx, from 1 to 3. Min u 42, I don't know what to tell you, it's 30. Same deal with 14. We have sine of 2x, again with the x-axis, from 0 to pi over 2. 0 to pi over 2. Sine 2x dx equals 1. Why do I bother? 15. Same deal. Negative 1 to 2. X squared minus 1 dx. You should get 8/3. 16. Alright, so this one, you really have to visualize it. So I'm going to draw you a graph here. Let's start with cosine. Cosine of 0 is at 1, and it slowly decreases. Sine starts at 0, and it increases. Now, where does it intersect? This obviously isn't to scale, but when does sine x equal cosine x? Well, if you look at your unit circle, you'll see that the point is going to be at pi over 4, and your values are going to be root 2 over 2. Perfect. So now that we have that information, we're looking for this value. Now on x, we're going from 0 to pi over 4, that point of intersection, and our y value is, this is our cosine, and this is our sine, so cosine minus sine. So our integral is from 0 to pi over 4 of cosine x minus sine x dx. And you can integrate that by hand. I'm sure you can handle it. It's going to be 0 to pi over 2 of sine x plus cosine x. I'm not going to bother plugging in. You could also do this with a calculator. Root 2 minus 1. 17. All right. This is an opportunity to show off exactly how cool your calculator is. I sincerely hope you have at least a TI Inspire, if not like a CX or a CX CAS. Now, I've already graphed it for you. Now, you're going to be able to do a lot without having to plug in to that gnarly equation every time. All right, part A. How many people have heard this rumor at time equals 0? Well, since it is time on the x-axis and number of people on the y-axis, you want to know when x is 0. So you can plug in f of 1 of 0, and it'll just spew out 1. A is 1. For B, how many people heard it at 10 minutes? Exact same process. F1 of 10. All right, now for part C, what is the largest number of seniors who might have heard the rumor? Well, you have 100 seniors. 100. There will come a point where everyone will hear the rumor. D, about how long will it take for 25 seniors to have heard the rumor? In this case, you have 25 seniors, which is your y-axis, or your y value, and you're looking to find your x value. This is when you employ numeric solve. So you type in solve, you open parentheses, and now you want your first parameters. So again, you're looking to find your x value, so x, and you want to find your x value when your y is 25, when you have 25 seniors. So your first parameter is your equation with only one variable, and your second parameter is the variable you want to find. And it should give you 58, roughly. Yeah, 58.275. And your units there are minutes. E. At what time is the rumor spreading the fastest? Now, if you look at the graph, the graph looks something like this. It starts to accelerate, and then it plateaus. Just looking at the graph, I can tell you it's going to be 50, which it is. Right? Because that's when you have the most number of people to tell and the most number of people telling. You just have to think about it. It's a lot faster than trying to actually calculate a derivative. Now, finally, how many seniors have heard the rumor at the time indicated in part E? So now we know that our x value, or rather our y value, is 50 seniors. So technically part E isn't done here. We have 50 seniors, we need to find the x value. So that's going to be another numeric solve. Numeric solve, f1 of x equals 50. Now find x. And you should get 76.58-ish people. Or sorry, minutes rather. F. How many seniors had heard the rumor indicated in that part? You just take F1, there's your x value, 50. That should be all. Sorry, I'm a little out of it. It is 10:40 p.m.